Okay, so to finish the question we were on at the end of the last video, we were doing the conservation of momentum on a 3 kilogram object that was rolling 5 meters per second east when it smucked into a 5 kilogram object initially at rest. After the collision, the 5 kilogram object went off at 2 meters per second east, and the question was, what's the velocity of the 3 kilogram object? So we did our conservation of momentum equation. We got rid of this term because it had no velocity initially. We brought over this term because we were solving for V1F. We filled in our numbers. The top gives you 15 kilogram meters per second minus 10 kilogram meters per second, which is not 10, it is 5. My math's good, eh? So 5 over 3 should be 1.6 repeating meters per second. It works out to be positive, so it will be east. Okay, so in grade 11 when we did these, every one of them went off in a straight, all stayed in a straight line. Well, I hate to tell you this, but in the real world, that doesn't happen. In the real world, they usually go off at angles. And if you've ever played pool or billiards, you would discover this, right? So that's where we get our two-dimensional. So we're going to look at conservation of momentum in 2 dimensions. Now the good news is the law of conservation of momentum works in holes in 1 dimension, holes in 2 dimensions, holes in 3 dimensions. It's a law. It's going to hold in all dimensions. Okay, so this time let's imagine we have our ball number 1 and it's rolling in, and we'll say the mass of our ball number 1 is 3 kilograms, and it's initially going, let's say V1 initial, let's make it 4 meters per second east this time. Okay, and it smucks into our ball number 2, and our ball number 2 this time is a little bit smaller. It's 2 kilograms. Okay, but it's still initially at rest, so V2 initial 0. Now, in a more real-life scenario, they're not going to go in straight lines. Instead, the first ball will probably go off at an angle. So draw our line here. So usually it says something like after the collision, the first ball moves off with a velocity of 2 meters per second at an angle of 36.87 degrees clockwise from its original direction. So clockwise from its original direction would be down here. So this is going to be V1F. This angle is 36.87 because they told me that in the question. And they told me it went off with a speed of 2 meters per second. So this is ball 1. If ball 1 goes off down this way, then you're pretty safe at betting the house that ball 2 is going to go up here. Okay, so this is going to be V2F, and of course this is going to be theta 2. And that's what the question asks. Find the velocity of the second ball after the collision. Remember, the velocity will be the length of this side, but also the angle that it's at. So the good news is conservation of momentum is like, or momentum is vectors. So like forces, you can apply it in the x direction and the y direction. So this V1F has an x component and a y component. So this will be V1y, V1Fy, and this will be V1Fx. And the conservation of momentum becomes x direction, m1v1 initial x, plus m2v2 initial x, plus dot 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 if there were more, is equal to m1v1 final x, plus m2v2 final x. So you're going to apply the law of conservation of momentum in the x direction, and then you're going to apply it in the y direction to get the 2 components that you're missing. And then once you have those 2 components, you can put them together to get your V2F. Okay, so in the x direction, V2 initial x is 0 because the V2 initial isn't moving. You know V1 initial, you know V1 final x, you don't know V2 final x. That's the one you're solving for. So bring your V1 final x over. So it'll be M1 V1 initial. Now if you look at V1 initial, it's completely in the x direction. So I can drop my x here because there's no y component. Minus M1 V1 F. If we look at our V1 F, it's the opposite side of this triangle, which means it is the sine theta, and that'll be equal to M2 V2 Fx. Solving for V2 Fx, so divide both sides by M2. Now don't fill V2 F sine theta in for V2 Fx, because that'll give you two unknowns. So just leave it as V2 Fx and solve for it. So V2 Fx equals, M1 was 3 kilograms, V1 initial, 4 meters per second, minus M1, 3 kilograms, V1 final, 2 meters per second, sine of 36.87, divided by M2, which was 2 kilograms. And when you do this, you should get a V2 Fx of 3.6 meters per second. Works out to be positive, so it must also be going east, just like V1 was. All right, now you're going to do the y. So it'll be M1 V1 initial y plus M2 V2 initial y. And if you had more objects, you just add them in, M3 V3, etc. And that's going to be equal to M1 V1 final y plus M2 V2 final y. Okay, so take a look at number 1. In the y direction, it's not moving initially. It's only going in the x. So V1 initial y is 0. V2 initial y is also 0 because it's not moving at all. So this whole side goes to 0. So you're left with 0 is equal to M1 V1 final, and the y component, oh shoot, I did y up here. I got the right answer though. This is cos, because it was x. And if I had actually tried to do it in my head, I would have discovered this. Sorry about that, that's cos. And this one is sine, because it's the opposite. Good to have your sine, your opposites and y's and x's in the right spot. And we're looking for V2F y. Okay, so take it over. V2Fy will be equal to negative M1V1F sine, for real this time, sine, over M2. M1 was 3 kilograms, so negative 3 kilograms. V1F was 2 meters per second. And, sorry, just fixing that too. This is cos. And then sine of 36.87 divided by M2, which was 2 kilograms, 0.6, 1.2, 3.6 divided by 2, 1.8. Negative, that's what I should have done on the top, and I would have found my mess up. The negative, what does the negative mean? Well, it means in the opposite direction to V1F. Okay, opposite. So V1 Fy was going down, so really this one means it's going up. We just didn't call down negative. Okay, so once you get, so opposite V1 Fy, therefore up. So once you get your F and your Y, your X and your Y, then you draw them. So you have 3.6 meters per second going this way. You have 1.8 meters per second going this way because it was up. So this is your resultant, and now you can find it. So this is going to be V2F, and this will be theta. Square them, add them together, take the square root, and you should get 4.0249 meters per second. And then inverse tan of 0.5 will give you an angle of 26.55 degrees. Which way? Well, it's going counterclockwise from